You probably have heard this term before, and it refers to the acronym Structured Query Language. This term refers to a programming language that allows for querying the data stored in an RDBMS or Relational Database Management System. The main four relational database management systems in use today in 2024 are MySQL, which after Oracle bought it in 2009 got forked in a new project named MariaDB. The next one is Postgres, which is one of the most feature complete. Next we have SQL Server from Microsoft, which is very popular in the .NET and Azure ecosystems. And finally we have SQLite, which is the most portable of them all, and likely the one with the most implementations, as it's in use in your phone as well as in your browser. So the main entity when we talk about SQL is the table. In the table we insert data in rows, where each row represents a single item of that table. Each row has the same number of columns. So we can have an field to store identity or identifier. Then we have another column with a different label, for example a name, and finally we have another element of date of birth. Each one of those elements in a relational database are called also attributes or fields. Now the table itself can have a name in order to help identify what kind of data it contains. Also, let's put some data into it so that we can play with it. So here we are making an SQL model where we have three tables: students, subjects, and student subject. Now, the student has a name with a field ID, which is the primary key of the table, or the field that helps us to identify unique elements in the table. Next one up, we have this other field, student ID, in the student subject table, which this is what is called a foreign key that goes from the student table to the student subject table, and that will allow us to make a relation between the first table, students, and the second, student subject. Then we have a second table called subjects, where we have an ID as well, which is a primary key and serves the same function as the ID in the students table. And this one is also connected through the subject ID into the subject students table. And all of this allows us to run a query that can lead us to know which students have enrolled in which subjects. Now let's move on, let's insert some data. This is done with insert statement, like the one that you can see on the screen. Now we are going to insert data into the students table. We're going to tell which fields are we going to insert with which values. So we're going to insert into students full name, date of birth, and then we're going to say inside those fields which items we're going to insert. Let's do the same for the subject table. Of course the names are a little bit different, but the concept is the same. And now let's have a look at the student subject table. We have to insert a student ID and a subject ID. However, we don't know which ones we have to use, which is why we identified those two with a question mark. Let's try to identify. Let's select everything from our students table. And this is going to return a table that contains the only student we inserted, which has an ID of 1. Now we do the same for the subjects, and we only have one item, which is biology, with an ID also 1. So now we can connect the two and do an insert into the student subject table, where we're going to put ID 1 into student ID and ID 1 into subject ID, so that we can do the relationship correctly. We also insert a date of enrollment into this table, which is the third field. Alright, so we put these two, and now we can move on, and we can insert some more data. So we're going to insert some data into the subjects, going to insert some data into students, some data with student subject, so that we can now play with the data. If I now run a select star on students table, I'm gonna get a list of my students with their date of births. I can now do a subquery. For example, I can only select a few fields from the students table, for example, full name and date of birth, which is going to return me the list of students with date of birth and full name. And now we can do the same, but with some more advanced query language, where we can say that, for example, date of birth needs to be greater than 1st of January 2002. And SQL will only return us the rows where the date of birth is greater than that such value. Let's move on to something different type of filtering. For example, we can say we want all the subjects which discipline is categorized as science, and this is the result that we get from our dataset. We can also do aggregates. For example, we can count how many students are in our students table with a count star. And now let's have a look at a join. Let's say we want to have, don't get scared by what you see on the screen, because it will be clear very soon. We want to know which students have enrolled in which subject and when. So we do a select where we take the students, subject and student subject table and we put all together through joins, where we match the student subject student ID with the student ID table, and then the student subject ID with the subject ID table. And the result is we can see that we get our student full name, the subject name, and when the enrollment was done. Now we can modify this query so that we get something a little bit more advanced, and we can say, for example, that we only want items with the subject of physics. It's going to return us the same dataset, but only with the students that enrolled in physics together with the enrollment date. And now we can also do aggregate joins. We can aggregate the data and, for example, count how many of these students have enrolled in which subject by doing a group by statement. So, and this is the result. So we know that, for example, the student Alice Johnson enrolled in 7 subjects, Bob Smith in 6, and so on and so forth. So this is everything for today's video. I hope you enjoyed it. If you did, please leave a thumb up and see you in the next one. Bye bye.